So thank you for attending this session on Codecamp 2021. My name is Alin Paraschiv and I work for Cognizat Softvision as a Java developer in Timișoara. Today I'm going to talk about the cache abstraction with Spring. I hope you find the content interesting and useful for you in your day-to-day job. So in the next 40 minutes, I'm going to talk about the following topics regarding cache. So I'm going to speak a bit about the cache, some cache generalities, cache patterns, and the focus will be the Spring cache abstraction and providers. Today I'm going to use one of the providers, which is Hazelcast cache, and architectural patterns that are possible. And at the end, I will have a customer case study and a demo. In the end, I will have a session of question and answers, hopefully as many as possible. Okay, so I'm gonna step right in the presentation so we can focus more on the demo part. So without further ado, let's deep dive. One question, what is caching? Caching is a technique where your application objects are stored in a temporary storage area known as cache. Cache acts as an intermediate low latency data source. Cache objects, they can be seen as key value stores and could be anything from, let's say, results of an expensive and time-consuming operation, a REST call for an API usually might be the case, or a database connection, also to static web pages, or as I was mentioning, the content of your backend database. Another thing to take into consideration when talking about cache is cache lifetime and expiry, which is known as time to live. It's cache basically is deleted after TTL expires. Another thing to have in mind is the cache eviction. It's the way of deciding which element will be evicted, basically deleted when the cache is full. Now the question, why do you need caching? Of course, one of the main aspects is that performance is improved by shortening the response time, the API latency, higher throughput, IOPS increased, and decreased resource usage for the application. You may add here a reduced database cost, because caching can take up additional traffic to its cache server, and by using cache, you will reduce the database traffic, and therefore you might reduce the database costs. Main situation where when to use cache will be concurrent requests and heavy read-write operations. That would be two situations where you can use it. Previously, I discussed about cache policy, the way how the items in the cache are evicted. There are 6 of them possible. The most used one is least recently used. Basically, it discards the least recently used entries first. Another one will be LFU, which basically behind the scenes will count how often an entry is needed, and those ones that are used least are discarded first. Then we have the LIFO, which basically last in, first out. Nothing to add here. Most recently used is discarding the most recently used entries, and it's contrasting with the RU, FIFO, which is first in, first out, and randomly delete an entry from cache. So these are cache policy that can be used. Caching levels, I mentioned this, so you basically understand where we're with the discussion. Basically, some caching levels are at the CDN or edge caching, at the browser level, at the database caching, and at the server caching, which is the focus basically for the discussion that we're having today. Okay. Now some caching patterns. Cache aside, read through, write back, and write around. We're going to discuss them in the next slides a bit. Cache aside, we have the application right here, we have the cache right here, and the database right here in this topology. And whenever application requests data from cache, it checks if that data is in the cache, and if so, it's a cache hit. If not, there is a cache miss, and therefore the application will request the needed data from the database, and the database will respond with the data, and that data will be updated to the cache also. That's with the cache aside. Now with the read-through, the cache is situated between the application and the database. And for a request of a data, it will request it from cache. If cache miss, then the cache will retrieve the data from database, update that data in cache, and return it to the application. Similarly to, we have a write through when we want to write in the we want to write something in the database. So first of all, we check the cache. Then, we're going to write the data immediately in the database, and afterwards it will be updated in the cache. That's with the write through. Write back. It's a bit similar with the write through, but the only difference is that the writing takes place not immediately, but once in a while behind the scenes. Basically, the cache flashes the data to DB periodically, so not immediately. Okay. Write around. With the write around, it combines a bit of cache aside and read through. Basically, the application writes directly to the database, and only data that is read goes to the cache. Now, which strategy to use? That's the question. So each strategy has pro and cons, and let's say for cache aside, we can name that resilient to database failures and down, simpler implement, and best for heavy read workloads. As a downside, the data consistency may occur between cache and database. Always a cache miss for the first time. Basically, the data is not in cache and adds some latency. For read-through, it's suited for read-heavy workloads when set of data is being requested frequently. And as a cons, always results in a cache miss for the first time. Data is not in cache as the cache side. For the write-through, data is always available in cache and won't result in a cache miss. It guarantees the cache consistency if we pair it with read-through. Also adds latency for write due to write to cache. For write back, it is suited for write-heavy workloads and reduces writes to database, and it's tolerant to moderate database failures. Permanent data loss may occur when cache fails as a con. Write around can be combined with read-through or cache aside and provides good performance in situations where data is written once and read less frequently or never. For example, when for real-time logs or chat room messages. As a con, it might be a bit complex than the others strategies. So having this in mind, we can choose one strategy that's suited for our needs. Now let's talk about the Spring Cache abstraction. This is the subject for today. As a dependency package, we are going to use Spring Boot Starter Cache. For configuring the cache, we have the annotation provided by the abstraction named Enable Caching. Also, we have the Cache Manager, which is an interface that deals with cache objects and executes the operations like cache create, destruct, and introspection. And we have the cache, which is a type-safe data structure that allows application to store the data temporarily, just like a key-value pair, similar to map. So whenever we want to use cache, we're going to use cache config, and we're specifying which cache to use. We're going to use the cacheable annotation for the method, and the cacheable annotation works simply. It will be executed, the method annotated with, if the cache value is not found in the cache map, and will not be executed if the cache value is found in cache map. We're going to discuss more on this annotation on the demo part, but I want to have a highlight of them. We're going to use cache put. With this method, basically, annotated with cache put the method will be always executed, and the result will be cached after it is executed. Cache evict, it tells to that method that annotated that it will delete the values from cache. So that's a short presentation for the Spring Cache abstraction. Now we're having support for Spring from a couple of cache providers. There's one generic, there's JHCache, EHCache version 2, Hazelcast that we're going to discuss today, Infinispan from Red Hat, Couchbase, Redis, and Caffeine. You can check Spring site for the latest available providers and versions. So that's it with cache providers. And as I was mentioning, we're going to discuss about Hazelcast, and Hazelcast offers some architectural patterns. We're going to discuss about the embedded cache, embedded distributed cache, and the client-server cache, cloud cache. We're going to have a pro and cons, and what are advantages of using one over the other at the end. So let's have a look on the embedded cache. This is the topology. we're having an application, and as I was mentioning, the cache is embedded to the application, and right here somewhere we have the database or the long-lasting call that will be improved by using cache. So we have another application here. It's identical to this one, but in the front of them we have a load balancer. So that's the topology for the embedded cache. And when a request comes, it will get to the load balancer, which will forward the request to one of them applications. And if the data requested is present in the cache, and it will be fetched from the cache. If not, the long-lasting call, it will be performed, and then the cache updated. The downside for this is that whenever a request comes from into the load balancer, it will forward to either one or either two nodes from one of these two nodes. But the thing is that if the same request will come and it will forward to the second node, then basically the cached value is in this node, and that's why it will fetch again in the DB, and it will lose additional time. That disadvantage will be eliminated by using the distributed cache. In this topology, we have the cache for the two applications shared in a cluster between the two applications. Now we have a third topology, which is the Hazelcast client server cache or cloud cache. So basically the request comes into the load balancer. It will enter either one application, either the second application, and will reach to the cache server, or this can be the cloud. Can be a cloud service for Hazelcast. Basically, it happens the same as I discussed previously. It will cache the value if it's not present in the cache server. Now, one thing to have in mind here is that the client library to communicate between the cache and the cache server is no longer limited to JVM-based languages, and has supports for other languages also. So that might be interesting for when you choose the topology that has to be used. Now let's see the pros and cons. So the embedded distributed cache has a simple configuration and deployment, low latency data access, and no separate ops effort will be needed. As a con, not flexible management. Basically scaling up and scaling down will be a bit challenging, limited to JVM based application, and that might be also a disadvantage that data is co-located with the application. As for the client server option, we have as an advantage data separated from application, separated managements for scaling and backup. Also, it's, as I was saying, it's programming language agnostic. As a con, separate ops will be needed, and it might have higher latency. That depends on the network connection that you're having between your application and the cache server. Okay, so I'm gonna discuss a bit about the customer case study that I worked for. As a tech stack, we use Spring Boot with Hazelcast, Java 11, and as a database we used Oracle. The context was heavy read-write operations to the Oracle DB data, and Oracle DB was behind a data REST service, which basically exposed the data from the DB as REST calls, and those were used for the ingestion. Basically, we're having a lot of gets, puts, and posts as HTTP requests. As architectural patterns, we use the embedded cache and embedded distributed cache. As cache patterns, we combine the read-through with write-through, so we get green cache always. And as a result, the ingestion process that I was discussing initially took around 20 hours, and after introducing cache, it was reduced to about 3 hours. So that was a success story, I would say. Now for the today demo, I'm going to have something similar, but with some simpler examples. We're going to use Spring Boot and Hazelcast cache, also Java 11. As a database, I'm going to use MySQL. Docker, we're going to use locally, Nginx as the load balancer. And also as architectural patterns, the same, embedded cache, embedded distributed cache, read-through and write-through. So let's start the demo. I have here something prepared. For the database, I have a Docker container with MySQL, which is already started, and I'm going to show the content of the DB. Here we have a simple book management application, and as fields we have an author, a name, and an ISBN, and the ID which is generated for each entry. This is what we have preloaded in the database as data. Also, I'm going to use a simple REST application to view the content of the resources, basically the books. So this is the book controller. Also, the book controller contains endpoints that are cached and endpoints that are not cached. This is one example, getting a book by ID without being cached and with being cached. So the result is cached. I'm going to show you the implementation for the get by ID. Basically, we're fetching a book by ID and we're returning it. And for the cached one, okay, now here we see the cacheable annotation, and I'm going to discuss about a bit what it does. Whenever a request comes, requesting a certain ISBN, then it will return from cache if it's present, and if it's not present, it will fetch it from the database and return it to controller. In order to showcase this annotation, I'm going to restart the application in debug mode, and I'm going to show you how things are working here a bit. So I have a request prepared here for that. Okay, it entered the controller, and let's see if that reaches the book service. because this data that I'm querying is already loaded in the cache, and I'm going to show you that later, but you'll have to believe me for now. This call won't be fetched from basically it won't reach to fetch the data from the, and if I press F9, there you go, it was fetched from the it didn't reach this call. So one thing to have in mind here is that if we execute the same, we're querying for the same ISBN book, but using the non-cached endpoint, I'm going to show you how that is happening. It takes about 313 milliseconds on my computer with this setup, and by using the cached one, you can see that it's lower in time, so the response is faster. That's one thing to have in mind. Okay, let's get back to the book controller. Now here, the annotation for the cacheable has some parameters, and I'm going to discuss about them. One is that specify which cache should be used, and I have one prepared. I'm going to discuss a bit that a bit later. A key and a condition. The key here is used is the parameter of the method. Basically, this is the key for the map, for the cache map. It's the ISBN. We are using this cache. We're having a map where the ISBN is the key and the rest of the book entity is the value. And the unless means that everything it will be cached except for when the result is null. So we don't put null values in the cache. Previously, I discussed about the initialization of cache, and this takes place in my application automatically when I started by having this method invoked here and this one here. Now, for this case, for this method, I'm initializing the cache, which is the book cache ISBN, and I put in the map the books, all the books, and the key is the ISBN, and the B is the book associated with that ISBN. There is another way we can initialize cache, and that depends on how we are deciding which are the keys. For example, we can use as key for the book, we can use an author and a name, because these two will result in a unique key, and that way we can ensure that the key is unique, and in this way we initialize the cache. Basically, that will be decided on when you decide what is the key for your cache. So that's one aspect to take into consideration. Okay, so cache it's initialized at application start. Now I have another controller here, which is a cache controller. Basically manages the caches that I created it. So for one cache, I can see the content, I can delete it, and I can see some details and statistics about the cache, how it is used, and other details in here. Okay, so let's see how this works. For that, I have prepared an endpoint, which is this one. Will fetch the whole content for the book cache ISBN. And the content is basically it's the whole database content that is here. We're seeing it in the cache. So this is the structure. This is the key and this is the value. The key and the value. All of the content is here. Now, what happens if we want to add a new book to DB? What happens with the cache? What happens with the cache if we want to update a given book? So for that, I have this request, which will create a book with this author, this ISBN, and this is the name. And the response will be that after the book will be saved in the DB, it will be updated in the cache also. So let's execute that. It was created, it's in the DB. Here it is. Now let's see if it's in the cache also. So I'm gonna request my endpoint, which shows all the cache map content. And here it is. It's this one. So the cache was updated. And how was that possible? By using the cache put. In similar fashion with the cacheable cache put, we need to specify which cache to use. What is the key? The key here is the book and the ISBN, of course. We have to be consistent with the key, and it will store the result of the return of what the method create returns only if the result is not known. So using cache put, we managed to add the book in the cache also. Similarly, for the update, I have a similar logic, so I won't execute that request for now. Well, I'm going to show you the delete, the cache evit. Cache evit means that I'm going to delete a book that I just created, and it will be deleted from the cache also. So let's first request the content of the cache. It here, let's delete it. Let's see the content again. It's no longer present, and of course it won't be in the database. It's clear. Now, this is what I wanted to show you as highlights for the Spring Cache abstraction. So we're having these annotations, cache put, cacheable, and cache config, which basically specifies which cache are available. Now, in the next part of the demo, the setup that I have here is going to be a bit similar to what I showed you in the presentation. And for that, I'm gonna show you this picture. Basically, this is what we're going to have here in this part of the demo. We're going to have a load balancer, which is a Docker container, and I use for that an Nginx image. the application, basically two applications that are also running as Docker containers, and they will have a distributed cache, and somewhere here we're going to have the same MySQL DB that I used for my previous example. So let's start that setup. I'm going to do that by, but let's stop. I'm going to raise the whole stack on the Docker Compose. Let's check the logs. It started. Now, what I want to show you is that if we are going to execute a request that queries the same ISBN, a cached value and a non-cached endpoint in terms of performance. So let's do that. So here we have the response for this. It's quite high, but it's a local setup. For the non-cached, it was faster, but if we execute this, you can see that cached responses are faster and faster. So basically, the cache endpoint is a bit more performant in terms of response time. So it's below 150 milliseconds, and the non-cached is constantly above 150 milliseconds. So we have a performance increase in here from that perspective. And I have another two requests here that we're going to launch them so basically this will be a concurrent request. So executed the non-cached endpoint, and this is the cached one, and this is the non-cached. And let's execute first the non-cached one. The total will be around 80 milliseconds plus the previous was 348, so 420 milliseconds around that values. And sorry, and for this one, as a concurrent request, we have, okay, let's execute it one more time. 100 milliseconds plus 377. So due to my setup and the Docker, sometimes it's the times obtained with the cache is a bit higher than the, actually not higher, it's similar to the non-cache, but in a production environment, that wasn't the case. So this is what I had to show you for today. If you have questions, I will gladly answer them.
Yes. First of all, thank you very much. Yeah, there is a question, at least one.
Okay.
False. Yeah, it was also in my
common
mind.
pitfall when using cache.
Because
besides the cache size, should we monitor other metrics and when using cache? Okay, basically that's, I think, a discussion whether what do we cache? Because I think that's the key aspect. Sometimes, as you might already know, that choosing cache is not a silver bullet, so it comes with downsides. But you have to choose it carefully in your let's say project or particular situation. That would be my answer. But other metrics, when using metrics like for example, I can say that response times will be one indication that something is not okay. But usually you'll have to find the root cause for the problem in the first place. After, you will have to decide whether we're using cache or what's the solution. So that would be my final answer to that. So response time, and I can tell that IOPS will be a good indicator that you can have in mind using cache.
Okay, thank you. The other point that I wanted us to tackle a bit more is about the caching providers.
Yeah.
And could we, I don't know, try to, when there is a default one, then I don't know, then people choose to use Redis, for instance. I mean,
yeah, I think Redis is the most popular.
From your perspective, I mean, what would you choose and when?
Okay, that's a discussion of performance and comparing different providers, and that's something that I, if I would say that you'll have to use that, then I think I will favor one provider, and I don't want to do that. Basically, you can check a basic comparison on what each provider is offering at the moment, because they constantly adding new features and performance enhancements, and it's always changing. So a decision will have to be made on a given moment by studying what's ideal for your needs.
So your answer is it depends.
I was going
Yes,
to say
the answer is depends. And for today, I choose Hazelcast just because I don't know, that was something that was available for them. But in some other cases, it might be Redis. In some other case, the default one that Spring provides. So it
All right.
depends, as I said.
Then, thank you so much, Alin.
Thank you.
Looking forward to having you sometimes.
Yes, I will gladly. Oh, okay. We have another one.
Yeah. You
How
want to
is
leave
this
us, but
better
we don't want to leave you.
managed on an auto-scaling environment? Well, I'm not sure which pattern you are discussing. The one that I. Okay, so if that's the case, then on an auto-scale. Yeah, okay, I see. The loading of the data was made just for showing that caching can be actually initializing the cache map can be made at startup of the application, but it can occur also on while running the application. You don't have to basically load the entire database into the cache. So there was one thing just for the demo scope, and I also showed that it's possible to add entities in the DB without having them already in the DB, so you can add. I'm not sure if I answered your question.
Okay, probably yes. I would say yes. You answered the question. Okay. Of course, I don't know, but yes, my opinion is yes. What's your opinion, Dan? Should we have a break?
I second that, and Dan says the same. So, well, the Dan who actually asked the question.
Yes, and thank you.
Okay, thanks, and thanks for the questions, and looking forward to have a presentation in person.